Today I am going to explain about hybridization. So what is hybridization? The mixing of atomic orbitals of equal energy to form hybrid orbitals, and this process is called as hybridization. Mixing of atomic orbitals of equal energy means it is an atom. So in this atom 1s2, 2s2, 2p2 orbitals are there. This is the electronic configuration of this atom, right? So here s and p orbitals present in the same energy level, that is 2. S and p orbitals are present in the second energy level, s and p orbitals. That means and these s and p orbitals have equal energy. So why? Because equal energy. Why? Because these two orbitals present in the same energy level 2. That's why s and p orbitals have equal energy. So these equal energy orbitals are mixing up to form hybrid orbitals. So these s and p orbitals are mixing up and combine to form hybrid orbitals. This process is called as hybridization. Is it clear? So why we need hybridization? Why we need hybridization? So hybridization is needed for, generally hybridization is, some molecules undergoes hybridization. Some molecules undergoes hybridization. Not all molecules, only some molecules undergoes hybridization. In some molecules, why we need hybridization? So consider it is an example. So A is an atom, right? So A is an atom, B is another atom. S and p orbitals present in the valency shell of A atom. S and p orbitals present in the valency shell, that means last shell of an atom. S and p orbitals present in the last shell of an atom, and in B atom only s orbital present. In B atom only s orbital present. So what happened here? In bond formation, here s and s orbital overlapping happened here. Here p and s orbital overlapping happened here in bond formation, right? So here ss orbital overlapping happened, here ps orbital overlapping happened here. So A atom cannot form two different bonds with the same atom B, right? So A atom, here different bond, here different bond, but same atom. So this is not possible. This is not possible. Why? Because any atom with the same atom cannot form two different bonds. A atom cannot form two different bonds with the same atom B. So this is not possible. That's why we need hybridization. That's why we need hybridization. In hybridization, what happened? In hybridization, what happened? So A atom, A is central atom, right? And here B atom bonded with A, right? So in what happened in bond formation, firstly the central atom, the orbitals present in the central atom, s and p orbitals, right? The orbitals present in the valency shell of an central atom, s and p orbitals are hybridized first. Hybridized and forms hybrid orbitals. These s and p orbitals are mixing up and combine to form hybrid orbitals. Hybrid orbitals means sp, sp, hybrid orbitals. So these hybrid orbitals are formed first in central atom, sp, sp. These hybrid orbitals are overlapping with s orbital of B atom, here s orbital of B atom. So here what happened? S and sp overlapping. Here also s and sp overlapping. So this is the way the atoms are bonded with each other. That's why we need hybridization. Is it clear? That's why we need hybridization. So at central atom, atomic orbitals are hybridized first. Then these hybrid orbitals are overlapping with the surrounding atoms. This is the way the atoms are bound to each other. That's why we need hybridization. So atomic orbitals of equal energy. That's why I am saying equal energy. Why? Because equal energy, the orbitals present in the same energy level. Same energy level. So the orbitals present in the same energy level having the equal energy. Equal energy. That's why the orbitals present in the same energy level are participating to form hybrid orbitals, and these hybrid orbitals are overlapping with the surrounding atoms of orbitals. So here s sp overlapping, here also s sp overlapping happen. This is the way the atoms are bonded to each other. That's why hybridization is needed. This is not possible. Why? Because S and S overlapping here, P and S overlapping here. A atom cannot form two different bonds with same atom B. This is not possible. That's why what happened? The orbitals present in the central atom firstly hybridized. And hybridized to form sp hybrid orbitals, and these sp hybrid orbitals are overlapping with surrounding atom orbitals. So here s sp overlapping, here also s sp overlapping happened here. This is the way to form bonds, atoms bonds to each other. Is it clear? That's why we need hybridization. These are the conditions for hybridization. So what is conditions for? So these are the conditions, 3 conditions for hybridization. So let's discuss about this. So first is only orbitals present in the valency shell of an atom hybridized. Only orbitals present in the valency shell, that is last shell of an atom. Orbitals present in the last shell of an atom are hybridized. That means inner orbitals present in the inner shells does not participate in hybridization. The orbitals present in the inner shell does not participate in hybridization. The orbitals present in valency shell, I mean last shell, the orbitals present in the last shell or undergoes hybridization. This is the first condition. And the second one is hybridized orbitals should have equal energy. Hybridized orbitals means these atomic orbitals, mixing of atomic orbitals have equal energy to form hybrid orbitals. That means the atomic orbitals have the equal energy, and hybrid orbitals also equal energy, should have equal energy. And the third condition for hybridization is number of atomic orbitals or mixing is equal to formation of atomic hybrid orbitals. I mean, so S and P orbitals are hybridized, then definitely 1 plus 1, 2 hybrid orbitals are formed. Number is equal. Number of atomic orbitals is equal to number of formation of hybrid orbitals. The number is equal. Definitely. So S and P orbitals can form 2 hybrid orbitals. Why? Because 1 plus 1. That's why number of atomic orbitals is equal to formation of hybrid orbitals. Number should be equal. These are the conditions for hybridization, right? Next, Uses of hybridization. So what is the use of hybridization? To detect the molecular geometry. That means to detect the molecular structure. Geometry means structure, nothing but structure. So hybridization is used to detect the molecular structure, molecular geometry. And the second use is bonding of orbitals present in molecules. Bonding of orbitals in a molecule. These are the two uses of hybridization. So hybridization is used to detect the molecular structure and bonding of orbitals present in the molecule. But here you have to observe one thing. Hybridization undergoes or does not undergoes all molecules. Hybridization undergoes only some molecules only undergoes hybridization, not all molecules. Not all molecules. So only some molecules undergoes hybridization, not all molecules does not undergo hybridization. Only some molecules undergoes hybridization, right? So we can find out the hybridization of any molecule. We can find out the hybridization of any molecule. I will explain later. Okay, so but only some molecules undergoes hybridization, not all molecules. Okay, so for example, diatomic molecules. Diatomic molecules does not undergo hybridization. Does not. Right? So diatomic molecules does not undergo hybridization. For example, H2, HCl, NO, like this. All these are diatomic molecules, right? So these diatomic molecules does not undergoes hybridization. Only some molecules undergoes hybridization. But we can find out the molecule is undergoes hybridization or does not undergo the hybridization. We can find out that. Okay, so the example for does not undergo hybridization is diatomic molecules. These molecules or does not undergo hybridization. So examples for it: H2, HCl and NO. Types of hybridization. So here I am saying some types of hybridization. One is sp hybridization and the second one is sp2 hybridization and the third one is sp3 hybridization and the fourth one is sp3 dehybridization and the fifth one is sp3 d2 hybridization. So these are the types of hybridization. Here what happened? In sp hybridization, 1 plus 1, s orbital, p orbital can combine to form two hybrid orbitals, right? Here, 1 s orbital, 2 p orbital combine to form 3 hybrid orbitals. And here, 4 hybrid orbitals. Here, 5 hybrid orbitals. Here, 6 hybrid orbitals, right? So I am saying number of atomic orbitals is equal to number of hybrid orbitals, right? So I am saying, so hybridization is used to detect the molecular structure, right? So in sp hybridization, what is the structure? Linear. Structure is linear. Why? Because two hybrid orbitals are there. That's why the structure is linear. And here 3, trigonal. The molecular structure is trigonal. And here 4 hybrid orbitals, right? So tetrahedral. Tetrahedral. And here 5 hybrid orbitals, right? So I am writing tri and bi. trigonal, bipyramidal. And here 6 hybrid orbitals. That means 6 means actually hexa, but here octa. Octahedral, right? So these are the molecular geometry of hybridization. So sp hybridization linear, in sp2 hybridization trigonal, sp3 hybridization tetrahedral, sp3d trigonal bipyramidal, and sp3d2 octahedral, right? Next, bond angles for hybridization, right? So bond angles for hybridization. So sp hybridization 180, in sp2 hybridization 120, in sp3 hybridization 109.5, in sp3 hybridization, sp3d hybridization, so 120 and 90 degrees, in sp3 d2 hybridization 90 degrees, right? These are the bond angles of orbitals present in the molecule. These are the structures, molecular geometry. Molecular geometry means molecular structure. In sp hybridization, molecular shows linear structure. In sp2 hybridization, molecule shows trigonal structure. And these are the bond angles. In sp hybridization, the bond angle between the orbitals is 180. In sp2 hybridization, 120. These are the bond angles of orbitals, right? Bond angles of orbitals present in the molecule. Thank you for watching.